Okay, so you guys were just explaining how much you love me. Thank you for that. And now we're going to talk about engines, just to get everybody up to speed, because not everybody's had engines. And those of you who had engines, quite frankly, I don't know if you learned anything. So, what? Did he just slam me? Okay, so most piston engines in aviation, and certainly most all piston engines on the road now, and dare I say in California, are four-stroke engines. There are such things as two-stroke, but they're few and far between anymore, especially in this state. So we'll talk about the four-stroke or the Otto cycle, because it was named after
Otto.
Four-stroke? Someone Otto.
someone's cycle. So the Otto cycle was named after Gregory Cycle. Okay. That's how the joke goes. Anyway, so in this what I have up here is a running operating engine, and it has 4 strokes. How many events?
2.
5 events. 4 strokes, 5 events. So a stroke is every time the piston goes from the top to the bottom or the bottom to the top. So I've got it going nice and slow here, and let's catch it at some point in the beginning. So we like to say the beginning starts with intake, where the engine is going to draw in fresh fuel and oil, which is where it is right now. Right? Hang on. We'll get it and we'll stop it. So you stop there. Here we go. Okay, so right now the piston is on its way down. It is creating a suction like a big syringe. It is sucking in fuel and air. This valve is opened up. That is the intake valve. There's a cam that goes up here that pushes on it. Well, you can see right here, this got a cam, got a push rod, a rocker arm. It's the same thing on this side, but they can't draw it because it would be sideways to that. And so it wouldn't make sense as you're looking at it, but just trust me, on the opposite side is the same thing. It's a rocker arm. So it pushes down on that little, it's poppet valve, but it's the intake valve. It's going to push down on that, and it's going to allow fuel and air to be drawn into the piston. So the cylinder. So the piston is pulling it, sucking it down. Continues to suck it down all the way, and then at this point, in theory, it doesn't actually, but as it gets to the bottom, we call it bottom dead center, when the piston is all the way out the bottom. And when it's all the way at the bottom, and this green thing right here, the crankshaft, is it easier if I walk back and forth? I guess I have to show it on here because I can't really too well see on the screen. But when this is the crankshaft in green, when it is perfectly all the way at the bottom, which I couldn't stop it there quite fast enough, and it's all at the bottom. Can I do that? Oh, look at that, I can. I just learned something. That is bottom dead center, where this crankshaft is lined up. This is the connecting rod, piston, piston pin. It's all lined up directly. The piston is as far as it goes. That is called bottom dead center. It is finished pulling in that fuel and air. It's going to start its way up. So as it starts its way up, notice that that intake valve is now closed. The piston is going to come up and squeeze the bejeebers out of it. Squeeze, 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 squeeze. And in this particular animation, the spark plug, which is right there in the middle, is going to see the little red dot, sparks. Now they have it sparking right at top dead center. That's not real. It would be if you were starting the engine, but in real life, that spark has to happen backwards down here. About 25 degrees of crankshaft rotation before top dead center. Because the spark plug ignites the fuel-air mixture, it starts this slow burn. It's not an explosion. If it's an explosion, that's called detonation or pinging. It will destroy an engine in seconds, literally. Put holes in pistons.
Dynamic dismantling.
Yes, in seconds. So it's a slow burning of the fuel. And so this slow burning starts, but that piston is moving fast, right? So here it comes. It's coming up. By the time it kind of gets to the top, the fuel has expanded, and now burnt and expanded, it will now start pushing the piston back down. So here we have spark, which is what we're going to talk about. The magneto creates the spark, and it pushes and causes the burning fuel, expanding fuel air mixture to push the piston down. It pushes it down. What happens now? And then it's all nastiness is because it's burnt, and it starts to push it out the exhaust and starts the entire cycle all over again. So that is what it does. So here we have compression, ignition, power stroke, exhaust stroke. Intake. So the 4 strokes are intake, compression, power, exhaust. Now, the 5 events are intake, compression, ignition, power, exhaust. Okay. So what we're going to study is what makes this spark happen. Now, in old-timey automobiles, I guess actually all automobiles, they rely upon the battery to create an ignition source. We'll talk about the old-style Kettering ignition system, which this one is represented because it's got a battery, it's got a coil, it's got a points, capacitor, a lot of the things you're going to recognize. And there's got to be a little bit more to it here, but no, I guess that's it. So, and so what that does is it creates the spark here, but you need a battery. Don't want that in an aircraft. So most automobiles only have 1 spark plug per cylinder. The exceptions being that I know of, would be, who makes dual spark plugs?
Rotaries?
Fords, right? Or Tritons.
Oh yeah, the old Fords, like old Ford, they had their
There's a few
4-liter in
engines
there.
that have-
There's a few. Mercedes had them for a while.
Mercedes had them.
Ford, I don't know Ford.
Ford did.
Nissan did.
Nissan, yeah.
Nissan did of all things. So I think Nissan gets a bad rap. I think they're actually good. So okay, so that's the 4-stroke engine. So before we move on to magnetos, let's talk about a more basic system that works off the battery. So we eliminate the electrical generating end. And we'll talk about the Kettering ignition system.
I've seen this one already.
Wh-
It's on YouTube already.
So did I.
Oh, then I can just go back to my office and take a break, and you guys can watch your YouTube.
Sounds like a plan.
All right. Well, this seems out of order. Well, I don't know why I did that. We'll do it this way. We'll do 2, then 1, then 3, because I want to. And then we'll see. We'll get to a point where I go, oh, that's why I did it that way. Okay. So, all right, Kettering ignition system. How do I want to do it here? I like to do it this way a little better. Okay, so in a battery ignition system, what do you got to have?
Battery.
A battery. So we'll make a battery, multi-cell battery. How many volts suppose that is?
12.
Why not 12 volts? Okay, so off that, the very next thing I'm going to need is a
Ignition switch.
ignition switch. So ignition switch. Now that ignition switch is going to go down to the coil. So inside of the coil we'll have, and they call it the coil, but what is inside of the coil? Coils and cores and other things. So we could make it look like this. Yeah, it would kind of look. Like that. So we got a coil that's in there. And
Is that like just the outer casing?
yeah, that's the outer casing. That's what you'd see. And of course, if I drew it correctly, a little wire would. Yeah, it doesn't work if I'm trying to be cool. So we'll just do it like this. So that wire is going to come over here, and we're going to run through one of these things, and then we're going to run it through. I don't want to do it. We'll go this way. There we go. And then, let's see. A lots and lots of windings, and that's going to go. Ground that out. And then we'll have it come out of here. I'm just not drawing. That's a 6. See, I left room for 6. But I don't want to draw them all.
Yeah.
So now
Yeah, it's a geometry.
I had a geometro. All right, just to make you happy. Be a 5-cylinder. Should have done 4. That would have saved time, and then I could have see world. All right, you got that all drawn up on there? Let's talk about what we've got going on here. So first thing, and I'll write notes for you afterwards. So first thing we got here is a battery, right? And so, well, this is the Kettering or battery ignition system. This exact style of system be used on older cars, not electronic ignition. So your Volkswagens, your old Vegas and Pintos and old boats and all kinds of stuff like that. Tractors. You might find it on some home builts because home builts use weird engines and stuff sometimes. But anyway, it's a good place to start. So we have a battery that is going to supply 12 volts to the primary coil. So that's primary coil right there. Primary coil. Well, not when it's open, of course, but when I close the switch, make it closed. There we go. So that's a switch. It's now closed. We have 12 volts running through the coil. So I have a primary coil. I turn on the switch, and what happens to the 12 volts out of the battery? It flows to where? To the primary coil. And then down through. We'll make that right. Oops. There. Down through the contacts. Now, you may remember from way time ago that you need a couple of things to make a circuit. One of those things is a path. If you don't have a path, you don't have current flow. Do I have a path?
Yes.
Currently, yes, I have a path. It starts in the battery, if we're going to do positive, goes through the ignition switch, which is now closed, down through the primary coil, finds its way through. It sees its capacitor. What does it do with the capacitor? Kind of sees it as an open, quite frankly, so it goes around over to here. There's a cam, and the cam may be open, may be closed, but when it's closed, it allows the current to flow through the points and back through to the battery. Okay, so we got a complete path going through there. So at the moment that I turned on the ignition switch and the points were closed, what happens? All right, so we've got current going through the primary coil. Current going through the coil creates what in the primary coil?
Relative motion or voltage?
Not yet. You got voltage.
Magnetic field.
Okay, you got voltage going through their amps. When you got a coil, you've made an electromagnet, right?
Yeah.
So now I have this electromagnet, and the electromagnet is probably, well, it's wrapped around an iron core. It doesn't look like that in the drawing, but it is. I've shown you guys the little coils right here. Coil around here somewhere. There we go. Thanks. So here we go. You got the coil, you got the core sticking out, and you've got some big fat windings, not too many of them, and then you've got thousands and thousands of little tiny windings. So we got, say, whatever, 100 windings right in this area. So we now have current going through the primary windings that are wrapped around that iron core. So that iron core and the windings, what happens there is you get this expanding field from the primary. Expanding magnetic field. That expanding field is movement because it's expanding. If I just turn it on and leave it like this, I have no expansion. Well, I do. I have it one time. Boom, on. That was it. Now it's expanded and it just stays right there. It doesn't do anything, so it's useless practically. Right? I got to get it to collapse and build up. Collapse and build up. Otherwise, it's useless. So, all right. So it builds up. And it's now that field, that force field, or magnetic field has cut across the secondary. But it really hasn't done anything, right? Because it just built up. And believe it or not, that's not when we're going to use it. So it built up, and it's just sitting there. So here we've got this field that has grown, and it's encapsulated the primary windings, but it hasn't done anything to them yet. So it's just sitting there. So what's going to happen is this cam is going to come around and start to open those points, right? And when it starts to open them, the current flowing through is going to want to jump this, but it can't because we have a capacitor here. And so as soon as we add some resistance to these points, the capacitor is going to look like a better path to the electrons, so they will back up, run into the capacitor. That's good. That allows the points to open. When the points open, the capacitor is charged. There's no way else for this current to flow through the primary. So it does what? Quickly, slowly, medium, as fast as possible. Right now. Violent, as instant as it can. Collapses across the secondary. When it collapses across the secondary, we have wire and magnetic movement. And that equals? Current flow. Wire, magnetic movement. Wire stays put, magnet moves. You everybody see that the magnet moved? Didn't really, but the magnetic lines of flux moved. So it goes across these windings here and creates a lot of voltage in this secondary. Comes out into the coil wire is what it's usually called, and into a rotating finger that will point to where it is supposed to send the spark to. And each one of these will represent a cylinder. So what I got, 6 cylinders here. So this little finger is going to rotate around and point at the right time. And this finger has to open at the right time that the points open. And so it all works together and points to the right cylinder. But we have all this voltage that goes. We'll jump a very small gap right here, go to the spark tube, the spark plug. And remember, we must have a complete path all the way around. So where's my path?
In the ground from
It's got to go from the ground
to the ground of the second coil?
to right there. There is a complete path. Now, how much voltage is built up in the secondary?
a lot. About 20,000 volts.
It's going to be 20 or more or less. Now, the funny thing is, how much voltage is built up depends on how much of a gap it has to jump.
Yeah.
Right? If it's a very, very tiny gap, it will only build up enough voltage to jump that gap and flow. Because it's an easy jump, so it builds up to that, flows, finds ground, it's done. Start widening the gap, and it has more to do. So it's going to have to build up to a higher voltage to jump that gap. That's why gaps are important, how big they are. Small is a very low voltage. It just jumps it, goes to ground, it's done. So, in other words, if you were to actually grab onto one of these wires, you're going to feel it, but it's not 20,000 volts because it doesn't have to be, because you have, well, could be, depends on your resistance. But a very small gap, not so much, big gap. So I start opening the gap, a little bit more voltage, a little bit more voltage, a little bit more voltage. What happens if I make the gap this big?
It's not going to be able to jump it.
Can't jump it, so where does the voltage go?
Straight to the distributed block.
Straight.
The cycle back?
Well, that's where we get into...
Doesn't flow 'cause there's no...
Okay, it may not flow, but it's going to try really, really hard to flow. And where it flows is going to be where there's a flaw. It could be, instead of sparking from here to this one right here, it may find its way over to this one because it was a shorter gap here. It may find a spot inside the coil where this wire is weak and it arcs to the case. It could be that it finds a spark plug wire that has got a bad spot and arcs to ground somewhere. So when you're playing with magnetos, and magnetos are the same concept, and you're just sitting there kind of spinning it and turning it and sparking it, it's got to be firing somewhere. And it is inside somewhere. And so you're just damaging it. Every time you do that, you're creating a weak spot inside of it. So on airworthy magnetos, don't do that. It's a bad thing. So, all right, what else can I say about this? That's about it.
And the magneto, it jumps 2 gaps then?
Even in, this is not a magneto, this is a battery ignition system. So you have 2 gaps that it jumps. One here, which is pretty small, and the other one was there, which is a spark plug. All right, want to write some notes? You would love to. Like, what did you just say? I don't know. Write some stuff. All right.
Words of
Wow, it's already break time? I feel like we just started.
Is it?
That went fast.
Because we started 15 minutes ago.
I know, we know that.
We need a break.
The YouTubes don't know that.
Also known as a, you want to go break now or you want to,
Yeah. No hesitation.
as a battery ignition system.
I go to break at 9:10.
Battery ignition system. All right, so if you want a break, we'll take a break.
What? No, 9:10. What?
What? Some people need a break?
You started late. Well, I don't want anybody to get all cranky on me.
Take a vote.
We won't be cranky.
By the time you get done with this vote, it'll be time for break is over. All right, we'll just go like another 15 minutes.
Yeah, just go 30.
All right. Yeah, we'll go till his hand hurts. That's good. Okay, also known as a battery ignition system. Make sure you know that because that's how I'm going to distinguish it on a test. Kettering or battery, so it's the same thing. So it was used on, now at this point, older cars. Older cars, some aircraft. I've never worked on one, I think, that has it. Some aircraft, like usually a home built. Usually home built. I think I had a friend with a Volks plane, had a Volkswagen engine. I think he had that kind of system in it. All right, so what is our principle of operation? Principle of operation. 1. So a battery supplies 12 volts. 12 volts to the primary coil. To the primary coil. What happens if the battery goes dead?
Oh, then the whole thing goes dead. What if you got your alternator gallon?
Just put a new battery in there.
Dropping it.
Okay,
Just go to AutoZone.
so just go to AutoZone. If the battery goes dead, he says the whole system goes dead, but you say, what about the alternator? Good question. If the alternator is working, then the battery won't go dead. So what happens if the alternator dies, which is actually a better question. And so, yeah, I like that one better. The alternator dies, then what happens?
Run off the battery.
You're just going to run off the battery. So if you're doing this at night, what are you going to notice?
The
Lights
are gonna
get
dim.
dim.
First, the lights start getting dim. Well, first you're probably going to notice that the speakers aren't working real well. Something's funny with the radio. That's probably your first clue. Then you're going to be like, that's kind of weird. You come to think of it, I can't see out the front very well. And it's getting darker than I thought it was going to be. And that's when you decide, it'd be a good idea just to switch it off and back on again to see what happens. And then the whole thing dies and you're dead. So don't do that. If that's happening, you have moments to get to a place to stop because your battery is dying. And that would happen to even a new car.
I've been in that position.
So have I.
And it was night. So,
It was
radio
night.
off, fan off.
It was on Highway 12. I was on the way to my ship, and I was in the Navy for ship's movement that day. We were leaving port, and I was going to be. You miss ship's movement in the Navy, and that's just, just not a good. Okay, so points. Points. What are points?
Contact points?
Well, if you're talking about mortgages, it's 1% of the loan. So don't pay points. So, but if you're talking about ignition system, points are that little switch, not the ignition switch. Where's the ignition switch? That's your key. So if I go back here, this right here, this is the key. That's the key. All right, when you turn it on. But your points are over here. sometimes called breaker points. The breakers or points. So breaker points. You can call them points, call them contacts. Who said contacts are good? So contacts go in your eye, they go in there. So, all right.
What do you mean overnight?
Points. Points. So points open and close. Open and close. Open and close via a cam. So a cam is just something that is not a circle, but it's an eccentric circle. It has a little bump on it. Maybe it has one bump. Maybe it has two. Maybe it has six. Maybe it has nine. It can do all kinds of stuff. And so when that little bump comes around, it would cause the points to open up. And then when the bump goes away, then they're going to go back down on the round part. As per this right here. If I can make that bigger. Oh, look at that. Do the magic of what's going on.
We learn a new thing every day.
I was like opposite though.
All right, so what they have here is, this is the cam shaft that's making this plunger go up and down here, this red plunger. That's what's opening the valves, cam shaft. Now they've drawn this back here as a cam for the points. You can see they're open right now. And they're going to come around this little flat spot, close, charge the system, and pow, open. Okay? Pow.
So is ours opposite then?
Nope, same thing.
The same?
Yep. Points open and close via a cam. Now this is going to be driven off the crankshaft. Off the camshaft. And it's important to note that the camshaft in the engine is the brains of the operation. The crankshaft is just the brute strength. So, I was trying to think of some characters. It's Pinky in the Brain. Was I? What are we going to do today, Pinky? Same thing we do every day. Try and take over this engine. Okay. And the reason why I say that the camshaft is the brains of the operation is because here's the green crankshaft going around and around. Exhaust, intake, compression. Does the camshaft know the difference?
No.
So in other words, if I were to roll this like this and say, you can't see what's going on, just look at the crankshaft, do you know what stroke it's on? It's up, it's down. And because it's going to go, I could say, well, there's intake, compression. You got to speed up for me. That's too boring. There we go. It could be intake. That could be power. That could be compression. You see what I'm saying? You don't know what's going on just looking at the crankshaft because it's just the brute strength. It has to go, it goes 4 strokes, right? It's got to go around twice to make everything happen. And you see that. It's very important. But the camshaft, I can see what's going on. Every time that goes up, that's connected to the exhaust valve on this side, so I can go, ready? Exhaust. Exhaust. Okay? And if it was drawn correctly, I could watch the intake go up and go, there's intake, there's exhaust, there's intake, there's exhaust. So the camshaft knows what's going on. It's got it. So that's why everything is done off the camshaft. And notice the speed at which they turn. The crankshaft is going to go around twice for every one time the camshaft goes around, because everything happens. Because if the crankshaft goes up and down twice, that intake valve only opened once, and the exhaust valve only opened once. So the engine has to go around 2 times, or 720 degrees, in order for that cylinder to do all 4 or 5 things. All right. So points open close via cam, driven off that cam shaft, because the camshaft is the brains of the operation. Camshaft, cam, I should say shaft. So because I said cam and then camshaft, so I'll try and be consistent. Camshaft turns at 1/2 the engine. The whole thing is engine. at 1/2 of crankshaft speed. We'll do this. Camshaft
Half the speed of crankshaft.
is directly linked to what is happening in the cylinders. This is where the crankshaft is not. Crankshaft just says up or down. The valves tell it what stroke it's on. And obviously I don't want my spark plug going off on the exhaust stroke. And what good is that going to do, right? And if I have it going off on the power stroke, well, it really wouldn't have been a power stroke. I mean, it's just not going to work. So you got to have the ignition is always going to be timed. We call it timed to what's going on inside of the engine. Because if you really think about it, one of the things as a mechanic we're going to do, we're going to do it even if you don't think about it, is that we have to tell this ignition system when to fire. And if you think about doing this, what if I took this little breaker point right here, and this is why this little nub right there, that's called the follower that rubs against that. If I took this whole little blue thing and I rotated it around so it was over here. We'll rotate it up a little bit. There we go. So I rotate this thing in the direction that the camshaft is going. So instead of being here, it's vertical over here. Nothing else changes. I just take it and start rolling it.
Advancing the timing.
Am I advancing the timing?
No, that's retarded.
Then the spark is going to happen later and later and later. So every time I take this little thing and I move it just a little bit this way, then if the nub is right here, it's not going to open until much later. If I do it over here, you can see it better. It's not going to, now it's going to open. So this opens, but then it would open there. Or if I turn it the other way, it's going to advance it. So that's one of the ways that you actually advance and retard timing on a car, is you literally take the distributor cap and rotate it in the engine, and it will advance or retard the timing. The same way a magneto works. I take a magneto and I plug it into the engine where it's supposed to be, and it's perfect. But if I take it and rotate it a little bit and then reclamp it to the engine, I've changed the timing, either retard or advance, depending on if it's a left-hand, right-hand, rotating magneto and all the other stuff. So, okay, now it's 8:30.